That's okay. Let's everything depends on your activity. So if you are just have muted your phone or your microphones, then it's like this. If you are active, I'm trying to answer questions. Okay, so in our case, we have an equation y prime is equal to x cube plus cosine of xy plus y times x. Can we be sure that the solution for y of 0 equal to 5 is unique or not? Is the second theorem applicable to our case or not?
Maybe applicable, maybe not. We need to prove it.
We don't know the derivative with respect to y.
What is the problem? You have the right-hand side. In our case, f of x and y is just x cube plus cosine of xy plus y x. If I calculate the derivative with respect to y of this function, then I will get, in this case, I will get just x times sine of xy, sorry, minus sine, yeah, plus x, yeah. So it's just the derivative with respect to y, okay?
Okay.
Is it continuous or not? Are both functions continuous?
Yes, it's continuous.
Yeah, obviously it's continuous. The sine is continuous function. Polynomial functions are continuous. If we add them or multiply them, they will be continuous. The problem may be when we divide some numbers, some functions by other functions. But when we add and multiply continuous functions, the result will be continuous. Okay? So the first function, the right-hand side of equation is continuous. The derivative of right-hand side is continuous. And so at the neighborhood of x0, y equal to 5, and the solution is unique. I understand that it's a little bit tough to work with objects that you cannot just feel. That's okay. We are discussing the existence of solution without explicitly searching for the solution. That's hard. We just discussed there exists an elephant, and unique elephant which has I don't know, a black left first leg. So we are discussing the existence of solution, and we just cannot solve this equation because it's too tough for us. It contains cosine of xy, and the function is inside. So it's a little bit tough to solve it, but we are discussing the existence of solution. Okay. Any questions for the moment?
Not yet.
Okay. I will try to answer the difficulties of Daria by solving a problem with resonating case. Okay, let's consider the second example. Question, I don't know, that's question 2. Okay. Let's solve two equations. So we will try to solve two equations. They will be quite similar, but with a subtle difference. I will have two equations. Equation A will be y prime prime minus 5y prime plus, plus 6y equals to 3 exponent of 5x. That will be the first equation. And the second equation will be a little bit different. I will have exponent of 2x. So that will be the unique difference between these two equations. And I will try to discuss the difference in the solution process. Okay. And my question is, let's solve them. Let's solve them. Okay, the problem is clear?
Yes.
Okay, so how will we start? Because the start for both equations will be common. How do we solve such
We
equation?
should say that y is equal to exponent in the power of lambda x, no?
Yeah, in step one, we will solve homogeneous equations. Let's solve homogeneous equation. So step one, we solve homogeneous equation. What does it mean, homogeneous equation? Well, y prime prime minus 5y prime plus 6y should be equal to what is a homogeneous equation?
0.
0, yeah. Thank you very much. Be active, please, because it's very awful when you are just quiet and it's not a lecture, it's your work. Who has already solved it? Who has found characteristic roots? Okay, then we just let's find the solutions of the form y of x exactly equals to exponent of lambda x. Yeah, we are searching for solutions of very special form. If we plug in this y of x, then we get that y prime of x is equal to lambda times exponent of lambda x, and the second derivative y prime prime will be equal to lambda q or lambda squared of x. Everything is okay?
Yeah.
Yeah.
We plug in these expressions in our homogeneous equation, and we immediately obtain the equation now looks like that. The equation now looks like that. We have y prime prime of x, then minus 5 y prime of x, and plus 6 exponent of lambda x, and it's equal to 0. We cancel the common factor exponent of lambda x because it's non-zero, even if x is a complex number, that's okay. It will not be 0 in any case. Okay, that's not a 0 even if we work with complex numbers. And then we obtain a characteristic equation. And the characteristic equation looks like lambda squared minus 5 lambda plus 6 equals to 0. What are the solution of this equation?
2 and 3.
Yeah, we have two roots of characteristic equation. Lambda is 2 and lambda is 3. We have the solution, the general solution of homogeneous equation y of x is c1 times exponent of 2x plus c2 exponent of 3x, where c1 and c2 belongs to the set of real numbers. Okay, we have solved the first step to both equations. Yeah, any questions up to now?
No, here no questions.
Now, let's move on to the difference between two equations, because now we see that the right-hand side differs a little bit. In the equation A, we have 3 exponent of 5x. In equation B, we have 3 exponent of 2x. Yeah? Let's solve the first one. So let's solve equation A. Step 2 for equation A. We see that right-hand side is equal to 3. Right-hand side is 3 exponent of 5x. And now we need to guess a solution. Let's guess a solution. We know that the derivative of exponent of 5x, if we will take the derivative once or twice or 3 times, or we will always get some number multiplied by exponent of 5x. And that's what we need in right-hand side. So I will try to guess a solution by just using the right-hand side as a guess. So my guess, let's write it, g of x is my guess. G of x is k, which is unknown constant for the moment, times exponent of 5x. So this is my guess candidate. Guess candidate for solution. Okay.
Okay.
I look at the right-hand side, I see 3 exponent of 5x, and I just guess, but when I take derivative, exponent of 5x will never change 5. Yeah, we may get a different coefficient before exponent, but not in the exponent, okay? When I take derivative, the coefficient before may change, but the coefficient inside exponent will never change, yeah? So if we have a guess, so we immediately see that g prime of x is equal to what? What should I add before k? Please, guys, be active. If it's very easy, just say that it's very easy. We'll go on faster. If it's too hard, just make a comment. I'm okay with negative comments, but when I have no comments and I just see black rectangles,
Sorry.
I cannot do better when I see black rectangles. So
Yeah.
just be active. Just say, oh, I understand everything. Oh, it's very hard.
Yeah, it's very hard. Yeah.
It's 5. So
Any other opinions?
It's 5x.
Yeah, it's 5x.
Oh, I forgot about x. Sorry.
No, it's 5k. No. We take derivative with respect to. Okay, so we have taken one derivative. So let's take the second. What will be the second? What will be the coefficient before k?
Just 25.
Yeah, 25. And now I plug in everything in original, not homogeneous, but in original equation. Yeah. If I plug in everything in the original equation, I will have that 25k exponent of 5x minus 6 times 5k exponent of 5x plus, oh, sorry, minus 5, yeah? Minus 5, yeah? Yeah, minus 5. Plus 6 times k exponent of 5x, and that should be equal to 3 exponent of 5x. Any questions?
No.
So let's simplify, and we immediately get that we cancel out exponent of 5x. It's positive number, or it's non-negative even if x is complex number. We cancel it out, and we get that 6k is equal to 3, and so k is 0.5. And we have guessed solution now. Guessed solution. So we have completely guessed the solution that g of x is 0.5 times exponent of 5x. And this guessed solution allows me to write the general solution of original equation. So general solution for that matter equation of equation A. What should I do with the homogeneous solution and this guessed solution?
Sum it up.
Yeah, I need just to add them. So I will just copy this line. And I will go here. And I will just add my 0.5 exponent of 5x. Okay, any questions?
No question. Everything okay?
No, here no questions, but how does it relate to the to the last lecture?
Yes, and now, Dasha, we will solve B, and we will see that we have a resonance case. Yeah. So
This is non-resonance case.
Non-resonance case. Here we go.
Why?
Yeah. But this strategy will fail for the problem B. Let's see why it fails. So let's use the same idea. Let's use the same strategy for the problem for the case B. So let's use the same strategy for the case B. So I look at the, so I will just copy that. So I look at the right-hand side. Step 2 for equation B. I see that right-hand side is 3 exponent of 2x. Yeah. And first idea is the same. First idea, let's do the same. Let's guess. This is guessed solution candidate. It is G. This is a guess. That's not a solution yet. Is K times exponent of how many x's? So what should I put here? 2, 5, 7, 19.
2x.
Yeah, 2x. Why 2x? Because my intuition is like that. When I take derivative, the coefficient inside my exponent will never change. It will be always 2. And when I will plug in this candidate into my equation, then everything will be fine. Okay, let's do like this. So I just will copy these lines and plug into original equation. So the only thing that will change, I will change the coefficient. It will not be 5, but 2. The second derivative will be not 25, but how many?
Four.
Yeah, it will be 4. It will be 4, 6 times. And up, you see the problem. Yeah, the problem is this strategy fails. Do you see where the strategy fails?
We can just minus two parts of the equation.
Yeah, the problem is that when you cancel exponent of 2x, you will get a problem. You will have something like 0 because 4 minus 10 plus 6 is 0. 0 is equal to 3. Oops. Oops. The guessed solution candidate is wrong. We have made a wrong guess. That's okay. So we need to make another guess. What was the problem? Why if we are attentive, we can see immediately that we will fail with such a guess. Let's discuss the reason why we failed with this guessing strategy and what should we do. So we have two questions: why we failed, and so it's not arithmetic error. It's a deeper problem. Our solution candidate was wrong. There are no solutions of such type in our case B. Okay, let's discuss why. If we look at the general solution of the first step, so let's look once again at the general solution of the first step. This is the general solution of homogeneous equation, okay? Just a small reaction. Okay, I understand, and we will continue. Just
Yeah, okay.
thank you.
Everything okay?
Yeah. And I see that if I take any C1, any C2, and if I plug in this solution of homogeneous equation, I will get 0. So if I have, for example, C1 equal to 5 and C2 equal to 0, so if I take any C1, any C2, and I plug in this homogeneous solution into my equation, I will get 0. So if I plug in exponent of 2x in my equation, I will get 0. If I plug in 5 exponent of 2x, I will get 0. If I plug in exponent of 3x, I will get 0. If I plug in 5 exponent of 3x, so if I plug in everything that is specified by this homogeneous solution, everything, I will get 0 and not the right-hand side. And if I look at what we have searched in case B, we have tried to search for non-zero right-hand side using exponent of 2x multiplied by k. But if I multiply exponent by any k, I will get 0. Okay? So we need to change the guessed solution candidate. Yeah?
Yes.
Okay. How we will change a guessed solution candidate? Who remembers from lectures what should we do? How we will change the guessed solution candidate? We will pre-multiply it by what?
By lambda, maybe.
Not by lambda. If we multiply it by any constant, once again, Dash, let's look at the meaning of this general solution of homogeneous equation. If you multiply exponent of 2x by any number C1, by any number, by 5, by 10, by lambda cube, by any number, and if you plug in the result in the equation, you will get how much?
Okay, 0, I see.
So what is the meaning of the general solution of homogeneous equation? If you take 5 exponent of 2x plus 7 exponent of 3x, and you plug in the original equation, because this is a solution of homogeneous equation, so you will get 0. If you take lambda 1 times exponent of 2x plus, I don't know, 75 exponent of 3x, and you plug in the original equation, you will get 0. You will not get the non-zero right-hand side. And our goal now is to have 3 exponent of 2x. So we cannot multiply it by constant. We need to multiply it by something trickier. And the idea is to multiply not by a constant, but by a function. Yeah. Which is the simplest function, non-trivial, non-constant you can imagine. What is the simplest function, non-trivial? F of x is equal to
X.
x. Yeah, let's multiply by x. So let's pre-multiply our solution candidate by x. So we'll have g of x is k times x times exponent of 2x. So we have multiplied not by a constant, because multiplication by any constant is useless. We will always get a 0 if we will try to guess any exponent of 2x multiplied by any number. Okay, so we have g of x. Let's have what is the g prime of x? What is the derivative of x multiplied by exponent of 2x? Who can give me? So there's a small question to you. I give you, let's say, 3 minutes. What is the value of G prime and G prime prime?
Is 1.
Sorry?
Yeah, 1.
It's k exponent 2x plus 2x k exponent 2x. It's the
Okay.
first one. And the second one, it's too long.
Yeah, that's 2x like that. Yeah.
Yeah.
Now let's continue with second derivative, G prime prime.
It's 2x k exponent 2x plus 2k exponent 2x plus 4kx exponent 2x.
Okay, let's simplify a little bit and we will get, let's simplify a little bit and we will get something like, I think, 4k, something like this, yeah?
Yes.
And now let's plug in everything in our original equation. So we plug everything in our original equation. So we have, this is our, I just recall that this is my original equation. Plus 6y of x equals to 3 exponent of 3 exponent of 2x. Okay, this was my original equation. And let's plug in everything. So it will be a little bit of work, but when you plug in everything, what do we get? We get, this is the first term. Minus 5 plus 6 equals to 3 exponent of 2x. And instead of y prime of x, I just get that expression. And instead y of x, I have kx exponent of 2x. So this is my new equation. What is the resulting, when you simplify everything, what will you get? So let's simplify everything. Alexander, Artur, David, Vika, what are you doing? Just if you are working.
Minus,
just...
it will be minus k plus 20kx equal to 3.
Oh, thank you, Dasha. Just give me some information, Alexander, Artur, David, Vika. So we are just listening. We cannot speak. Just because I don't know whether you understand everything, whether just a little bit, a little message, and that's okay. If I'm going too fast, too slow, you understand nothing. You understand everything. Please be active. Just one word, and it will be better.
Yeah, I'm listening. I'm just looking at the solution.
I understand that you are more or less active, so I'm okay. I will just go on. Okay, we will have x times exponent 2x will disappear completely, and I will be left with so if I look, I will be left 4. So exponent 2x will disappear. So in right hand side, I will have just 3. In a left hand side, I will have just 4 k. That will disappear minus 5k, I think, like that. Equation will be very simple. Yeah.
Yeah, sure, like that.
Okay, and now finally I have k is minus 3. And I have a guess solution. It's a little bit more difficult than in case A, because it's minus 3x exponent of 2x. And the final answer is I need to copy my so general solution of equation A. And I just take minus 3 times x times exponent 2x. Okay, any questions?
No questions, everything okay?
So, and Daria, basically this phenomenon is called resonance. The problem is that the right-hand side has exactly the same structure as solution of homogeneous equation. And in this case, when the right-hand side coincides with solution of homogeneous equation, then the solution of non-homogeneous equation will be multiplied by x, or maybe by x squared, or maybe by x cube, if there are more repeating roots of characteristic equations. But basically, we need to multiply by x. If it will not work, we will multiply by x squared. If it will not work, we will multiply by x cube. If it will not work, we will multiply by x of more and more higher power. And by looking at the structure of solution, we can find the power of x, which is sufficient to have a solution candidate. Okay?
Yeah, okay.
So basically that's called resonance, and maybe Kirill Alexandrovich was proving something, or I don't know. So we have found that it was about resonance and non-resonance case. So we have two cases. Case A is without resonance. Case B is with resonance. Okay. Oh, I think let's, what we can do. My question is, yeah, you can follow the link and you can go up and down. So if you don't see something, then you can just follow the link I have sent in Zoom chat, and you can scroll up or scroll down and see everything we have discussed. My question, whether do you prefer, so because for me it's okay if we continue like that. When I type formulas or when I write formulas, I'm more or less indifferent, because I hope I will find the pen today, or I will buy it tomorrow. So what is for you, what is more more useful? Beautiful formulas typeset with exponent and so on, or writing by hand? What is the best from your?
Typing.
Typing is more clear, I think.
Yes, I understand that it's more clear, but maybe I can draw easily errors from there, from here to there. Or, I may annotate. I think that I may draw. Yeah, I think I may. Yeah. Okay, I may annotate and draw here. Okay, yeah. I can draw. How to remove it? T. Okay, let's finish for today. So my main message: I will be happy to answer your questions, but please provide me some information. The name of a concept, probably some keywords, at least. Dash, okay? I'm really trying to help you and to answer your questions, but at least some piece of information, not names of theorems, I don't know, screenshots, anything is okay. So I will do my best to understand your question, but believe me, when you say I have understand nothing, and what we can do with such vague information, believe me, I'd like to help you. From my viewpoint, we are doing the same thing. So from my viewpoint, students and teachers are not against each other, but we are doing the same goal. We are trying to communicate, to learn how to solve problems, and basically.
Yes, thank you.
Okay, so have a nice day. See you next time. I don't know yet how I will do lectures without pen, but I will try to find it. If not, I will do with formulas in
Thank you. Goodbye.
notebook. Okay, bye-bye. Thank you for your
See you later.
patience.
Bye-bye.